Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to be doing some guided practice with sequences, which again is a topic that frequently appears on both arithmetic reasoning as well as the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB. More specifically, in the first part of this video, we're going to get practice finding the next term in a given sequence. After that, we're going to take a look at some arithmetic sequences, and more specifically, we're going to find the nth term as well as sum all the terms in those arithmetic sequences. As I mentioned in yesterday's video, you have to be able to do both things in order to be successful on the ASVAB. And again, you might only see one or two of these questions on the test. As always, I strongly encourage you to make an effort to work out these practice problems on your own scratch paper. That is, after I read a question, you should pause the video, attempt to work out the question on your own, and then resume playing the video to see if you and I came up with the same solution. So all those things being said, let's go ahead and get started. Instead of finding the next three terms in the sequence, we're just going to find the next term in each sequence. And again, on the ASVAB, you're either going to have one of three questions regarding sequences. Find the next term in the sequence, find the nth term in the sequence, which would make it an arithmetic sequence, or find the sum of the terms in the sequence, which again would be an arithmetic sequence. So we're going to take a look at all those things. For number one, we can see that we have 1, -3, 9, -27, and 81 in this sequence. And right away, we should see that it alternates between 1, -3, 9, -27. So in light of that, I know that this sequence has to be multiplied by a negative number for that pattern to occur. So let's see if we can figure this one out. To go from 1 to -3, I can multiply 1 by -3. To go from -3 to +9, again, I can multiply by -3. Again, -3 times -3 is +9. To go from +9 to -27, again, I can multiply by -3. So as we can see, the pattern in this case is multiplication, albeit by -3. So to go from -27 to +81, again, multiply by -3. So that means to find the next term in this sequence, we're going to multiply 81 by -3. Again, positive times a negative is going to result in a negative number. So let's work this out. 1 times 3 is 3. 8 times 3 is 24. So we can see the next term in this sequence is -243. Again, as far as these first few questions go, in which we're finding the next term in the sequence, there's no real way to go about doing this other than trying to discover the pattern that holds true for the sequence. Some people are very good at that, whereas others are a little bit slower to pick up on the pattern. That said, make an effort to struggle to see the pattern, because the more you get practice doing these, the better you'll get at that. I know I probably make it look easy because I'm pretty good at recognizing patterns. But that said, there was a time when these questions were challenging for me as well. So just keep practicing, which again is the purpose of today's video. Let's go ahead and take a look at number 2. You can see we go from 9 to 109 to 209 to 309 to 409. So this one's pretty easy to see. To go from 9 to 109, we're adding 100. To go from 109 to 209, we're adding 100. To go from 209 to 309, again, we're adding 100. And to go from 309 to 409, we're adding 100. So to find the next term in this sequence, we're simply going to add 100 to 409, which is going to be 509. Given that we added a constant of 100 to go from one term to the next term in this sequence, this is an arithmetic sequence. And given that we multiply by a constant of -3 to go from one term to the next term in this sequence. We know, especially if we watch that video I uploaded yesterday, that this is a geometric sequence. Okay. All right, so let's go ahead and move on to number 3. As we can see, we have a sequence from 0 to 24. We want to find this next term in the sequence. To go from 0 to 3, we would add 3. To go from 3 to 8, we would add 5. To go from 8 to 15, we add 7. So as we can see, we're adding by consecutive odd numbers in this case, 3, 5, 7. To go from 15 to 24, we add 9. So to find the next term in this sequence, we're simply going to add 11 to 24. And in case you can't do that in your head, we can work it off to the side. 4 plus 1 is 5. 2 plus 1 is 3. So we can see the next term in this sequence is, in fact, 35. All right, number 4 is very, very challenging. If you can't see this one, just bear in mind that this is one of those very difficult problems that even someone with a degree in math would have trouble figuring out right away. But that said, we can see that we go from 1/2 to 1/2 to 3/8, 1/4, and 5/32. This one is involving something that's going on in the numerator as well as the denominator. And let's go ahead and think about it this way. This is our A1 term, that is our first term. This is our A2 term, our A3 term, our A4 term, and A5 term. And if we look at this one and play around with the numbers, which you would have to do a lot in this case, we should realize that the pattern to this one is n over 2 to the n. Okay, and that's all there is to this one. And let's see if this holds true. So a to the 1, that means n is 1. So let's see if this holds true for number 1. Let's plug in, and again, this is in the n1 position. So this is 1 over 2 to the 1, which is the same as 1 over 2 to the 1 is just 2. All right, let's see if it holds true for the second term. We have term number 2, so we know n is going to be 2. So this is going to be 2 over 2 squared. So this is going to be 2 over 4, which can be reduced to 1/2. All right, let's check this third term just to see if this pattern holds true. And if it does, we know we can use this right here to figure out the next term in this sequence. So again, we're checking this pattern for the third term, our n equals 3. So this would be 3 over 2 to the third. This is 3 over 2 to the third. That's 2 times 2 times 2, which is 8. So we can see that for the first term, second term, and third term, this holds true. So let's go ahead and apply this to the next term in this sequence, which is going to be a to the 6th. So that's going to look like this. 6 over 2 to the 6th. And to find 2 to the 6th, we have to realize that this was 2 to the 5th. So it's going to be 32 times 2, which is going to be 6 over 64, which we can reduce, of course, given that 2 goes into 6 as well as 64. We can divide this by 2 as well as 2. 6 divided by 2 is 3. And 64 divided by 2, well, 2 goes into 6 3 times, 2 goes into 4 2 times. So we can see that the next term in this sequence is 3 over 32. Again, very challenging problem. You probably won't see something like that on the ASVAB, but it's a good question to get your critical thinking going. All right, let's move on to number 5. Let's see if we can figure out what's going on with this pattern. We go from 4 to 16 to 36 to 64 to 100. This one should be pretty easy to see, given that these are all perfect squares. In fact, 4 is the same as 2 squared, 16 is the same as 4 squared, 36 is the same as 6 squared, 64 is 8 squared, 100 is 10 squared. So I know the next term in this sequence is going to be, and again, these are even, so 2, 4, 6, 8, 10. It's going to be 12 squared, which is 144. Okay, so that one wasn't too difficult. Let's take a look at number 6. We have 14, 34, 54, 74, 94. To go from 14 to 34, we would add 20. To go from 34 to 54, again, we would add 20. To go from 54 to 74, again, we add 20. And to go from 74 to 94, we add 20. So clearly the pattern is to add 20 to each term. So to go from 94 to the next term in this sequence, we're going to add 20. So that's going to be 94 plus 20. In case we can't do this in our head, let's work it off to the side. 4 plus 0 is 4. 9 plus 2, 9, 10, 11. So the next term in this sequence is 1, 1, 4, 114. All right, so for number 7, we can see we have some fractions. And in case it's not obvious, this first term in the sequence is also a fraction. Again, we can write whole numbers as fractions by placing them over 1. So now that we've done that, we should see what the pattern is. The numerator stays 5 no matter what. So I know the next term in the sequence is going to have a 5 in the numerator. But in the denominator, we can see we multiply by 2. Again, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So I know this denominator is going to be 16 times 2, which is going to be 32. So the next term in this sequence is 5 over 32. Right, number 8 is pretty challenging as well. As you can see, the terms in this sequence are -9, 101, -999, 10001, and -99999. So this again is kind of a pure test of your ability to recognize patterns. In this case, it should be obvious that, again, we're going from negative to positive to negative to positive to negative. So I know the next term in this sequence is going to be positive. And at the same time, you can see that we're dealing with 9s as well as 1s and 0s. In this case, we have 1 9, 3 9s, and then 5 9s. Okay? So the 9s are increasing by odds consecutively. And in this case, we have zeros that are sandwiched by 1s. In this case, there's 1 0, 3 zeros. And so I know there's going to be 5 zeros in this next number. Again, it's positive, so it's 1, 5 zeros, 1, 2, 3, 4, 5, sandwiched with another 1. Okay, so the next number in this sequence is that number. So that's it. Again, apart from number 4, you should expect to see at least one of these questions on either the arithmetic, reasoning, or mathematics knowledge subtest of the ASVAB. So as I mentioned in yesterday's video regarding sequences, I stressed that you should definitely learn how to find any given term in an arithmetic sequence, as well as how to find the sum of an arithmetic sequence or series. And these next few questions are in regard to finding the nth term of an arithmetic sequence. And in yesterday's video, I pointed out that you can do this very easily using a formula. And it's one of the formulas I recommend that you memorize. That is a to the n, and again, n refers to the nth term, equals a to the 1. A to the 1 refers to the first term in the sequence, plus d. D is the common difference, that is the constant that gets you from one term to the next term in the sequence, times n minus 1. And again, that m is the nth term that you're trying to find. So using this formula, we can quickly solve any problem like this. If you're doing really well on the ASVAB, you might see a question like this, in which case you'd be dead in the water unless you use this formula, especially if you're asked to, as you can see, find the 23rd term in a sequence. So let's go ahead and work on doing that. For A, let me go ahead and label what we have. We have a to the 1, a to the 2, a to the 3. And we're being asked, as you can see, to find the 7th term. So that looks like this. Again, we're going to use this formula. A to the n equals a to the 1 plus the common difference times n minus 1. We know what a to the 1 is. It's 7. We know that we're going to be finding the 7th term, so n is going to be 7. That said, the one thing we do need to figure out is the common difference. That is, we need to figure out what gets us from 7 to 11, as well as from 11 to 15. Some people find this by subtracting the second term from the first term, but more often than not with arithmetic sequences, it's pretty straightforward to find. To go from 7 to 11, that's 4. And to go from 11 to 15, that's plus 4. Again, arithmetic sequences are a constant that gets you from one term to the other via addition. And as we can see, that's what we have in this case. We have a constant of plus 4 getting us from 7 to 11, and likewise from 11 to 15. So let's go ahead and write down our d. Again, we found that to be 4. So let's go ahead and plug everything into this equation. Given that we have everything identified, a to the n, again, we're finding the 7th term, so a is going to be to the 7. A to the 1, as we pointed out right here, is 7, plus d. The difference is 4 in this case, and again, that's the common difference between consecutive terms. It's going to be constant for the entire sequence. So this is going to be plus 4. Again, n is 7, as we can see over here, so this is 7 minus 1. A to the 7 equals 7 plus 4 times 7 minus 1 is 6. Let's keep working this out. A to the 7 equals 7 plus 4 times 6 is 24. A to the 7 equals 24 plus 7 is going to be 31. Okay? So the 7th term in this sequence is 31, and that is the answer to this question. Again, if you have an arithmetic sequence, you can use this formula right here to find any term in the sequence pretty quickly. Let's go ahead and take a look at B. It's going to be the same process, again, but in this case, we want to find the 23rd term. And again, you could do that by, constantly adding the common difference, but again, that would take you a long time, and you would be very prone to make an error as you did that. So let's go ahead and get started with this one. Again, if it's helpful, we can call this a to the 1, a to the 2 for the second term, a to the 3 for the third term. So again, we're going to be using this formula. A to the n equals a to the 1 plus d times n minus 1. In this case, we know what a to the 1 is. It's always the first term in the sequence. We know n is going to be 23 since we're trying to find the 23rd term in this sequence. But that said, we need to figure out what the common difference is, and more often than not, that's pretty easy to do with arithmetic sequences. We want to ask ourselves what will take us from -7 to -5. Of course, that's plus 2. What's going to take us from -5 to 3? That's going to be plus 2 as well. So we can see our common difference, our d, is going to be just 2 in this case. So with all those things identified, our a1, our common difference, and the formula written down, We can solve this one, so let's start plugging things in. Again, this is going to be a to the 23rd equals a to the 1, which is -7, plus common difference, which we identified as 2, times n minus 1. Again, n is 23, so that's 23 minus 1. A to the 23 equals -7 plus 2 times 23 minus 1 is 22. Let's go ahead and work this out to the side if we can't do it in our head. And that's 22 times 2. 2 times 2 is 4. 2 times 2 is 4. So this is a to the 23 equals -7 plus 44. And if you can't do that in your head, you can work it off to the side as well. This is 44 minus 7. 4 minus 7 we can't do, so we have to borrow. That becomes 3. That becomes 14. 14 minus 7 is 7. 3 minus nothing is 3. So we can see that a to the 23 equals 37. So in other words, the 23rd term in this arithmetic sequence is in fact 37. Okay? Let's do 2 more of these just to make sure we got them down. And let me erase that real quickly. All right, so for C, you can see we have 3 terms in a sequence, notably 18, 11, and 4. And we want to find the 6th term in this sequence. Again, in order to do that, we're going to make use of this formula. A to the n equals a to the 1 plus d times n minus 1. Again, that's one you should memorize. We know what n is. It's going to be 6, since that's the 6th term we're trying to find. We know what a to the 1 is. Again, a to the 1 refers to the first term in the sequence, which is right here, or 18. Now we just need to find the common difference, or d, and the common difference is what takes you from one term to the other. That is what takes you from 18 to 11 in this case. That's going to be -7, and to go from 11 to -4, we can see we're going to have to subtract by 7. So the common difference, or d in this case, is -7. All right, now that we've identified everything, let's go ahead and plug it in. Again, this is a to the 6, since we're trying to find the 6th term in this series. A to the 1 is 18, plus common difference, -7, times n minus 1. Again, n is 6. 6 minus 1. And these become pretty simple once you have everything figured out. 6 minus 1 is 5, so this is -7 times 5. A to the 6 equals 18. 7 times 5 is 35, so this is 18 minus 35. In case we can't do this one in our head, let's go ahead and work it off to the side. This is the same as 35 minus 18, but we know our result's going to be negative. 5 minus 8 we can't do, so we have to borrow. This becomes 2. This becomes 15. 15 minus 8 is going to be 7. And then 2 minus 1 is 1. So we can see that a to the 6 is -17. Okay, and finally, we're going to go ahead and work on d. As you can see, we have a sequence going from 3 to 4 with 3 terms. Again, a to the 1 is right here. A to the 2 is right here. A to the 3 is right there. That is, first term is a to the 1. Second term in the sequence is a to the 2. Third term in the sequence is a to the 3. I'm going to do this work off to the side so we can have more room. So again, to find the 16th term in this sequence, that's going to be a to the n equals a to the 1 plus d times n minus 1, where d is the common difference. We know what a to the 1 is. It's the first term in the sequence, or 3. We know what n is. It's the nth term that you're trying to figure out. So n is going to be 16, both here as well as here. That said, we need to figure out the common difference, or d is. So as we can see, we need to figure out what will get us from consecutive one term in the sequence to another. So to go from 3 to 3.5, we add 1/2. To go from 3.5 to 4, we add 1/2 again. So the common difference, our d in this case, is going to be 1/2, given that we add 1/2 to go from term to term in this sequence. So with everything identified, let's go ahead and plug things in. And we're trying to figure out what the 16th term in this sequence, so that's a16 equals a to 1. A to the 1, that's 3, plus the common difference, which we figured out was 1/2, times n. N is again 16 minus 1. Okay? So let's work this one out. Again, this is a16 equals 3 plus 1/2. 16 minus 1 is going to be 15. A16 equals 3 plus half of 15 is going to be 7.5. Okay? And we can represent that as a fraction or a decimal. But in this case, since it's given in fractions, since we have fractions in the sequence already, let's just represent it as a fraction here. So again, 15 times 1/2 is 7.5. Let's go ahead and add these. This becomes 3 plus 7.5, so that's going to be 10.5. So the 16th term in this sequence is 10.5. All right, so in yesterday's video, I also mentioned that you need to know another formula regarding arithmetic sequences, and that was how to find the sum of arithmetic sequences or series, and that's given by this formula. S to the n equals n times a1 plus a to the n all over 2, where a to the 1 is the first term in the sequence, n is the final term in the sequence, a to the n is the final term in the sequence, and so on. So in this case, we want to find the sum of the numbers in this series that starts at a to the 1 and ends at a to the n, which is 101. In order to do this, we have to figure out what n is before we can apply this formula. So in order to do that, we're going to have to make use of this formula again. Again, a to the n equals a to the 1 plus d times n minus 1. And by solving for n, we'll figure out what a to the n is here. And that will tell us what number this 101 is in this sequence. And we need that to use this formula. So let's go ahead and work on that. Again, that's going to be a to the n. Again, we're still trying to figure out what n is. A to the 1 we know is 5. The common difference, or d, is something we can figure out pretty quickly. What takes us from 5 to 9? That's 4. What takes us from 9 to 13? That's going to be 4. So we can see that the common difference, or d in this case, is in fact 4. So d is 4. And this is going to be n minus 1. Again, we don't know what n is. And again, I pointed out that a to the 1 is the first term, and a to the n in this case is the last term in this sequence. So we can actually plug in 101 in place of a to the n as our next step. So this is going to be 101 equals 5 plus, again, common difference we identified as 4. So this is 4n minus 1. All right, now using some very basic algebra, we can figure out what n is. So let's work this out. This is 101 equals 5 plus, and again, instead of knowing what n is, we're going to take this 4 and distribute it to n, as well as this -1. So this is going to become 4 times n, or 4n, and then 4 times -1, which is -4. So this becomes 101 equals 5 plus 4n minus 4. Let's combine like terms. 5 and -4 is just 1, so this is 101 equals 1 plus 4n. Subtract 1 from both sides since we're trying to solve for n now. This crosses out, leaving us with 101 minus 1, or just 100, equals 4n. Divide both sides by 4. This crosses out, leaving you with just n over here. And 100 divided by 4 is 25. So we can see that n is 25, which means that this 101 is a to the 25. In other words, it's the 25th term in this series or sequence. So with that out of the way, we now know what n is, and we know what a to the n is. So we can just plug these values into this formula to figure out what the sum of all the numbers in this sequence or series is. So that's going to be sum. Again, we figured out what n is. It's 25 equals n. Again, n is 25 times a to the 1. That's 5 plus, and let me get rid of this real quick so it's not in our way. Plus a to the n. Again, a to the n was 101 all over 2. So this is s to the 25 equals 5 plus 101 is 106. So this is 25 times 106, all divided by 2. In order to make this a little bit easier, I'm going to go ahead and reduce this by dividing just 106 by 2 to get rid of it from the denominator. So this is going to be s equals 25. 106 divided by 2. 2 goes into 10 5 times. 2 goes into 6 3 times. So this is the same as 25 times 53. And we can work that off to the side as needed. That's going to be 53 times 25. 3 times 5 is 15. Carry the 1. 5 times 5 is 25, 26. Add a 0 before we start this number. 2 times 3 is 6. 5 times 2 is 10. Let's add. 5 plus 0 is 5. 6 plus 6 is 12. Carry your 1. 1 plus 2 is 3. And 1 plus nothing is 1. So this is going to be 1325. In other words, if you were to sum all the numbers in this sequence or series between 5 and 101, which is 25 terms, the answer you would come up with would be 1325. Okay, and again, in order to figure out what term this was in this sequence, we had to use this formula. Once we figured out what n was, we plugged it into this formula, which made it pretty easy to solve. All right, let's do another example of that one, and then we'll move on to the final variation of these arithmetic sequences. So in this case, again, we can see a to the 1 is 83, whereas a to the n, which is the final term in this sequence, is 5. In order to apply this s to the n summation formula, we have to figure out what n is. So let's go ahead and do that. Again, we do that using this formula. A to the n equals a to the 1 plus d times n minus 1. Again, we're trying to figure out what 1 or n is. We know what a to the 1 is. It's 83. And to find d, or the common difference, we're just asking ourselves, what does it take to go from term to term in this arithmetic sequence? To go from 83 to 80, we subtract 3. To go from 80 to 77, we subtract 3. So the common difference is negative 3. All right, with those things identified, we can plug things in. And again, in case it's not obvious, we know a to the n is 5, so that's going to be 5 equals a to the 1, 83, plus common difference, which is negative 3 times n minus 1. This is 5 equals 83 plus 3 times, negative 3 times n is negative 3n. Negative 3 times negative 1 is going to be positive 3. So let's rewrite this without this plus minus there. 5 equals 83 minus 3n plus 3. Let's combine like terms now. We have 83 and 3, so that's going to be 86 minus 3n. Let's try to solve for n now by subtracting 86 from both sides. This is going to cross out, leaving us with 5 minus 86 over here. It's going to be negative 81 equals negative 3n. And again, we want to solve for n now, so we're going to divide both sides by -3. This is going to cross out, leaving us with n on this side. So we can see n is equal to -81 divided by 3. Let's go ahead and work that out. That's 81 divided by 3. And since this is a negative divided by a negative, we know it's going to be positive. Quick way to know if a number is divisible by 3 is by adding the terms in the number. 8 plus 1 is 9. So given that the summation of 8 and 1 is 9, I know this number is going to be divisible by 3 evenly. 3 goes into 8 2 times without going over. 3 times 2 is 6. 8 minus 6 is 2. Drop down our 1. 3 goes into 21 7 times without going over. 3 times 7 is 21, so we can see there's no remainder. In other words, n equals 27, so we know this 5 is a to the 27, or it's the 27th term in this sequence, our series. So with that information, we can now figure out what the sum of all the terms in this sequence or series is. Again, we do that using this formula. S to the n equals n times a1 plus an all over 2. And we know what n is now. The final term in this sequence is 27. So this is s to the 27 equals n is 27. So this is 27 times a to the 1, which is 83, plus a to the n, which is 5, all over 2. So this is s to 27 equals 27 times 83 plus 5 is going to be 88, all over 2. Again, to make this math a little bit easier, and my pen's starting to act up a little bit. To make this math a little bit easier, I'm going to do 88 divided by 2 real quickly. 2 goes into 8 4 times. 2 goes into 8 4 times. Okay, so we know this is 27 times 44. Let's work that off to the side. That's, again, 44 times 27. 4 times 7 is 28. Carry your 2. 4 times 7 is 28, 29, 30 when we add the 2. Add a 0 placeholder before we start this number. 2 times 4 is 8. And then 2 times 4 is 8. Let's add. 8 plus 0 is 8. 0 plus 8 is 8. 3 plus 8, 8, 9, 10, 11. So we can see the sum of the 27 terms in this sequence or series is 1188. Okay? And again, if you're doing really well on the ASVAB, you might see some problems of this nature. So just bear in mind that, again, just memorize these two formulas for arithmetic sequences. In addition to seeing them on the ASVAB, they also show up from time to time on other standardized tests, especially the GRE and SAT. So I'll just keep that in mind. All right, so we're going to do 2 more problems, which are very similar to the last 2 we just did. And that's going to be it for today's video. If you can do everything in today's video, you're going to be set in terms of dealing with sequences as well as arithmetic sequences on the ASVAB. Some of these take some practice to do, but as you can see, the algebra and the mathematics is very, very simple. So let's go ahead and work on B and D, and then we'll be done. For these problems, we're being asked to find the sum of the following series or sequence. And again, in case it's not obvious, the ASVAB is only going to test your knowledge of summing series if they're arithmetic in nature. You're not going to have to know how to find, as I mentioned yesterday, the sum of geometric or other sequences on the test. So again, we're going to make use of this formula, s to the n equals n times a1 plus an over 2. And for b, you can see that we're trying to solve for 10 terms. So we know our n is going to be 10. That said, we don't know what a to the 10 is, so we're going to have to figure that out first. And again, that's going to give us, this is a to the 1, a to the 2. We're going to need a to the 10 to plug in for this a to the n before we can use this formula. So again, we're going to revert back to this formula. A to the n equals a to the 1 plus dn minus 1. And in this case, we want to find this a to the nth term, which is going to be a to the 10th term. So this is going to be a to the 10 equals a to the 1, which is the first term, 19, plus the common difference. Again, the common difference is the number that takes you from term to term in the sequence or series. In this case, we need to figure out what will take us from 19 to 13. It's going to be negative 6. So we know our common difference, or d, is negative 6. It's going to be negative 6. Again, n is 10, so that's minus 1. So this is going to be a to the 10 equals 19. And I'm going to get rid of this plus since it's superfluous at this point. And we're going to go ahead and do this arithmetic real quick. 10 minus 1 is 9. Negative 6 times 9 is, let's see, negative 6 times 9 is negative 54. So we know the 10th term in this series is going to be 19 minus 54, which we can work off to the side right here. Again, this is how you do subtraction, do the arithmetic of subtraction. 19 minus 54 is going to be negative, since 54 is greater than 19. That said, in order to do this arithmetic, we have to do 54 minus 19. Just realize our result's going to be negative. 4 minus 9, we can't do. We have to borrow. This becomes 4. This becomes 14. 14 minus 9 is 5. 4 minus 1 is 3. So we can see the 10th term in this series is negative 35. All right, so with that done, we can go ahead and apply this formula now. Again, that's going to be s to the n equals n a1 plus a to the n all over 2. Again, in this case, we want to find s, the summation of the first 10 terms in this series. So that's going to be s to the 10 equals n. Again, that's 10. A1 is 19. It's the first term in the series or sequence. Plus a to the n, that's the final term in this series or sequence, and we found that to be 35. All over 2. Let's keep working this out. I think I'm running out of space down here, so I might have to move it over here. Again, we got to do 19 minus 35. So that's going to be 35 minus 19. But since 35 is greater than 19, we know the result's going to be negative. 5 minus 9 we can't do. We have to borrow. This becomes 2. This becomes 15. 15 minus 9 is going to be 6. 2 minus 1 is 1. So we can see that this is the same as 10 times negative 16 all over 2. All right, so let's go ahead and finish this one up. If you want, you can make this easier by reducing negative 16 by dividing it by negative 2. Again, negative 16 divided by 2 is going to be negative 8. So this becomes 10 times negative 8, or negative 80. Okay, so the summation of the first 10 terms in this series is negative 80, as you can see. Okay, so pretty simple there. Again, you have to get comfortable making use of both formulas in multiple ways. All right, so let's do D and call it a day. In this case, we want to find the summation of 8 terms, so we know our n is going to be 8. Again, we got to figure out what a to the 8 is to use this formula, but we know what a to the 1 is. It's 9. So let's start by figuring out what a to the 8 is, and I'm going to skip a step here. This is a to the 8 equals a to the 1 plus d n minus 1. In this case, we know what a to the 1 is. It's 9 right here, negative 9. So this is a to the 8 equals negative 9. Common difference is what it takes to get you from term to term in the arithmetic sequence or series. So to go from negative 9 to negative 1, we had to add 8. So we know the common difference, or d, is 8. Let's plug that in place of d now. That's 8. N, of course, is 8. So that's going to be 8 minus 1. Let's go ahead and work this out. This is a to the 8 equals 9 plus 8 times 8 minus 1 is 7. So this is a to the 8 equals negative 9 plus 8 times 7 is going to be 56. Let's work this out now. A to the 8 equals 56 minus 9. If you can't do that in your head, let's go ahead and do it off to the side. 6 minus 9 we can't do. This becomes 4. This becomes 16. 16 minus 9 is going to be 7. So we can see that this is going to be 4 minus nothing, which is 4. So a to the 8, in other words, is 47. All right, so with that, we can figure out what the sum of all the terms, 8 terms in this series or sequence is. It's going to be s to the n equals n times a to the 1 plus a to the n all over 2. Again, a to the 1 is the first term in the sequence. A to the n is the final term in the sequence, which we figured out to be 47. Let's plug things in and solve. Again, this is going to be the summation of the first 8 terms in this sequence or series. N is 8, of course. First term is negative 9. Second term, or the final term, is 47. That's all over 2. Oh, 8 to the 8. Yeah, that makes a lot of sense there. S to the 8 equals, let's go ahead and work out this arithmetic. Again, this is the same thing as 47 minus 9. Again, we can't do 7 minus 9, so we have to borrow. This becomes 3. This becomes 17. 17 minus 9 is 8. 3 minus nothing is 3. So this is 8 times 38 all over 2. In this case, I'm going to reduce this 8 to make this problem a little bit easier. That is, I'm going to divide 8 by 2. So this is going to cross out, and 8 divided by 2 is 4. So as we can see, s to the 8 is the same thing as 4 times 38. So that's 38 times 4. 4 times 8 is 32, carry your 3. 4 times 3 is 12, 13, 14, 15. So we can see that the sum of the 8 terms in this series or sequence is in fact 152. Okay, so that is it for today's video. I hope you found it helpful. Again, on the ASVAB, you should expect to have to deal with series at least once or twice across both the arithmetic as well as the mathematics knowledge subtest. Again, I mentioned that in addition to being able to find the next term in the sequence, you also have to be comfortable working with arithmetic sequences to find the nth term, as well as the sum of all the terms in the sequence or series. Admittedly, some of these topics are pretty challenging, so just bear in mind, if you're going to score somewhere between 70 and 99, you definitely want to be proficient working with arithmetic sequences. That said, regardless of what you're going to score, you are going to see problems in which you have to find the next term in the sequence, as we did for these first 8 problems. So if you like the content I'm creating, please consider subscribing to my channel. Again, I anticipate covering every topic that you could possibly see on the ASVAB by the end of August, if not sooner. In addition, you're more than welcome to leave some feedback in the comment section below. Again, some of the problems we looked at today were pretty challenging, so just bear in mind that some of the problems are challenging, and that's just the nature of some of the topics that I'm covering. It has nothing to do with the way I'm covering them. But on that note, I'm going to go ahead and cut you loose.